Was the Big Bang the beginning of the universe, or did something exist before it? Brian Cox is one of the most famous and popular physicists in the English-speaking world. No one explains the structure and meaning of the universe as simply and understandably as he does. Brian Cox now broke his silence and for the first time provided a convincing and fascinating answer to the question of before. Brian Cox on the Big Bang. The Big Bang happened everywhere, so the universe is not expanding into anything. Brian Cox clears up one of the most common misconceptions surrounding the Big Bang. We often think of this starting point as happening at a specific point, but Cox explains that there was no central point of the explosion because the Big Bang was everywhere. The explanation is quite simple. The universe did not begin suddenly and then expand in a previously empty space. Rather, the Big Bang and the expansion of space are one and the same. So you and I sit today, quasi in the middle of the Big Bang, or better said, in the consequences of the Big Bang. We have originated, just like myriads of stars, planets, and other cosmic phenomena, from the Big Bang. If we imagine the beginning and the expansion in this way, our conception of beginning, space, and time changes. The wonder and mystery of cosmology are suddenly all around us, and we are an integral part of it, no longer mere observers. But this idea also makes it clear how difficult it is to look back, because everything has changed in the meantime. Nevertheless, these possibilities exist because scientists say that the structures are the same today as they were immediately during or after the Big Bang. That's approximately like if you consider inflating a balloon. If there were points on it, they would change clearly by the expansion and would wander on the surface. Despite the change, the structures can be traced back to the beginning. The mystery of time cosmology offers another exciting effect. When we look into the sky, we literally look into the past. We see the remnants of that tremendous explosion. Every point in the universe today was part of that original moment. Inflationary theory offers an explanation for how the universe could expand so rapidly in an instant, to where it's going, and possibly how it will eventually end. At the moment, researchers believe that the expansion will not last forever. Either the universe will eventually freeze because it runs out of steam, it will rupture because it's overstretched, or it will contract again like a rubber band to possibly be reborn. The problem with the story is that so far we have no evidence to support these assumptions. Neither the Big Bang has been proven 100%, nor the expansion. Everything is based on observations and model calculations that try to trace phenomena existing in the now back to a starting point. But this is more difficult than it looks at first. We might think we are at one point today, and the Big Bang was at another point 13.75 billion light-years away from us. But this is a fallacy. The Big Bang happened everywhere, and time is also everywhere. We cannot see these quantities on a linear scale of measurement and then put them into relations where one followed the other and something followed nothing. Nevertheless, the universe is based in a certain way on relations or the dependence of certain sizes from each other, with which we manage very well via calculations based on these relations and sizes. Einstein formulated the theory of general relativity in 1915 and described the physical sizes of the three-dimensional space and time. The theory has since been supported by many actual proofs. These include the expansion of the universe discovered by the American astronomer Hubble in 1929, as well as effects of gravity, gravitational lensing, space-time curvature, and the effect of time dilation. Nevertheless, even Einstein could never describe what time really is. He suspected that time is only an illusion in people's perception. St. Augustine, also known as Augustine of Hippo, was an early Christian theologian and philosopher who lived from 354 to 430 AD. With respect to time, he offered some of the earliest and most profound reflections on the nature of time. He noted that time is difficult to define. Although we all know what it is when asked, he wrote, "What then is time? If no one asks me about it, I know it. But if I want to explain it to someone who asks, I do not know. Augustine argued that time does not exist independently of human perception. He distinguished between the past, present, and future, noting that the past and future are not real. In some sense, the past no longer exists, and the future has not yet begun. Only the present, which seemed fleeting and elusive to him, can be truly real. But how is it now if light, which was 13.5 billion years in the universe on its way, meets the observation mirrors of our telescopes? One would have to assume that this light was emitted from one place and now arrives at another place. But remember, we are in the middle of the Big Bang, and the Big Bang still expands today with us in the middle. You realize then that the light did not really travel through space from one point to another. Rather, the effect of space and time comes from the expansion. What was before the beginning of the temporal perception? Even if time exists only in our perception, it is still real to us. Time periods begin, pass, and end. Again, we have the idea of a beginning and an end. For Augustine, only God existed outside of time as an eternal being who created time and space itself. Albert Einstein looked at time from a physical perspective. Einstein's special theory of relativity already introduces the idea that time is not uniform everywhere in the universe. If we take the example of the balloon again, you can easily understand with your imagination that time may pass faster at the tip of the balloon than at the widest part. Einstein did not see time as something absolute, but as something related to other things, especially speed and gravity. The exciting question arises: whether we, as part of the balloon, can find out what was its beginning, and whether there was something before the balloon appeared, is a question that has puzzled scientists and physicists. If we believe the explanations of Brian Cox, then this is possible. The Big Bang, as the beginning of time, presents the concept of singularity, a state in which there was no time, no space, and no matter. However, the question is, where did this singularity come from, and did it exist within time? These questions are not easy to answer for scientists and physicists today. To understand these complex processes in every detail, we use the help of machines and simulation programs that can be fed with large amounts of data and then calculate different scenarios compatible with the known values from physics and mathematics. According to the calculations, there was nothing before the Big Bang. However, quantum physics teaches us that nothing cannot truly exist. Nothingness is a collection of particles constantly appearing from a field, interacting, neutralizing each other, and then disappearing again. None of these particles takes an existing shape. The fluctuation measured by our physical standards is nothing, zero, and yet it is something, pure potential, though not formed. Brian Cox puts this knowledge together with other models of cosmology and explains that before the Big Bang, there was no matter, but there was an ocean of energy, almost still but gently undulating. Although this place did not contain any structures, the energy had an effect on space, eventually causing its expansion. In the beginning, the expansion was not the gentle and sometimes almost sluggish evolution of the cosmos that we see today, but an unimaginably violent moment with forces at work that we find difficult to imagine. If we take the figurative idea of a sea of energy and put it together with the ideas of singularity, we have, instead of a point in which everything was concentrated, a whole carpet of many points. However, the Big Bang is supposed to have started from only one of these particles due to an irregularity in Brian Cox's gentle energetic waves. What we see today exploded, generating tremendous forces, initially resulting in incredible heat. As it expanded, the universe slowed down and cooled, allowing elementary forces of electromagnetism, radiation, and gravity to form. Particles began to find each other and form structures that were the basis for things like our human DNA, planets, plants, and of course, stars. Einstein doubted the concept of before the Big Bang. He considered discussions about what happened before the Big Bang to be pointless. In his opinion, there could have been nothing before this event that humans could grasp. However, This conclusion challenges the fundamental concept of cause and effect relationships in physics. Every effect must have a cause or reason in physics, but Einstein's notion that nothing existed before the cosmic singularity seems inappropriate. Brian Cox's model of quantum fluctuation is today already an accepted extension of standard cosmology. Although we know it can describe these effects, at the threshold of quantum mechanics begins a world that we can hardly measure and describe. Heisenberg called this threshold the fuzziness. So far, we cannot decipher the blueprint of matter in the here and now because our measurement methods fail at this threshold. Brian Cox's picture of the particle carpet does not contain any measurable quantities. Quantum physics has found another exciting effect that may give us an idea. The basic building block of the universe is information, and this can neither be created nor destroyed. Our universe was born with the basic features of spreading and changing information. If this information cannot be created or destroyed, it must have been already contained in the singularity, or in this neutral energy carpet from which everything originated. Information is not neutral, and it is not nothing. Therefore, we must assume today that the information from which our universe was built is eternal. If you love impressive videos like this, then subscribe to our channel.